An object is released from rest at a height h above the ground and falls freely in a uniform gravitational field. At time t after being released, it's fallen a distance s and is at a height h above the ground, travelling at speed v. The graph shows two quantities plotted. Which of the rows shows a possible pair of quantities for the axes? So naturally you might think, how do any of these quantities depend linearly or quadratically on the x-axis terms here? So let's start going through each one by one and trying to eliminate and then see which could be the possible quantities for the axes. So h, we know h is capital H minus s. And we know s from Suvat is a half gt squared. So if you've done a lot of Suvat, you should remember that whenever something is dropped from rest, then its displacement from where it drops is half gt squared because ut is 0, and then the gravitational acceleration is g. So you can see h depends on time quadratically, so it's not 1. What about kinetic energy? Well, we know that the kinetic energy plus the gravitational potential energy at height h is equal to whatever the initial energy is. So we could call it mg capital H, or we could call it initial energy, EI. So if we rearrange that, we get kinetic energy equals the initial energy minus mgh. So it varies linearly with h, and it's decreasing. So 2 is a possible quantity. Now, what about the gravitational potential energy here? So we could say that the gravitational potential, GPE, we could say it's equal to mgh, maybe plus some reference factor. So it could be 8 or whatever it is that we'd want to say the gravitational potential is at height 0. Or if we were to measure based on gravitational potential at the top, then GPE could also be written as the GP at the height h, and then take away mgs. So the gravitational potential energy at the top might be something like 8 or 10, and then if we've fallen a distance s, then it will be this takeaway mgs. So this is a possibility as well. So 2 and 3 only would be the possibilities.